In the profundities of the room, the James Webb Space Telescope has seen something absolutely stunning. Splendid lights, shockingly suggestive of Earth's clamoring urban areas, radiating from Proxima Centauri B, an exoplanet 7 trillion miles away. Are you prepared to face what lies past the stars? Might we venture to stop and think about what could be possible in finding a progress not our own? What privileged insights might they at any point hold? And what does this mean for humankind's future? As the world wrestles with the ramifications of this alarming find, the James Webb Telescope's most recent perceptions suggest that beyond what simple, arbitrary light could be, these may be conscious signs from a high-level progress on Proxima Centauri B. Each glint and move quickly over this gigantic distance welcomes hypotheses that we may be near the very edge of the most stupendous revelation in mankind's set of experiences: contact with a different universe. This portion of space, once thought quiet and barren, presently murmurs of conceivable life. With each piece of information, we inch nearer to potentially modifying history. As the telescope investigated the immensity of space, it found something entrancing on Proxima Centauri B. The far-off exoplanet transmitted lights that look like those from urban communities on Earth, indicating the conceivable presence of an outsider human progress. This thought has produced significant energy and interest among researchers. It very well may be the discovery they've been hanging tight for, highlighting the presence of keen life structures who may be coordinating their networks in ways we've never imagined. David Kipping, a cosmologist at Columbia College, described the planet where these lights were found as particularly complex. This intricacy emerges on the grounds that, unlike most rocky planets that assimilate daylight and radiate infrared energy, this exoplanet acts distinctively because of its extraordinary relationship with its star, Proxima Centauri. Yet, this isn't the only wonderful perspective. The discovery by the James Webb Space Telescope highlights just how powerful this apparatus is. The telescope's capacity to distinguish infrared light was key in seeing these surprising lights, showing us how much more there is to gain. The intensity signals from Proxima Centauri B are vital for understanding what its atmosphere may be like. Researchers need to keep utilizing this telescope to look into the planet's air and to investigate whether it might actually support life. The James Webb Telescope excels at recognizing infrared light, which assists it with noticing Proxima Centauri B's nighttime activities. Many space telescopes struggle to take note of faint lights in the vast obscurity of space, yet the James Webb Telescope can catch even the smallest flickers. This makes it ideal for checking if the supposed city lights on Proxima B's dark side are truly artificial. The telescope can distinguish any artificial lights in space if they emit within a particular narrow frequency that is much better than normal starlight. Proxima Centauri B has a close relationship with its star, as the side facing the star would have numerous solar chargers accumulating energy from the intense sunlight, while its dark side would also reflect some light. As Proxima Centauri B circles its star, it experiences a constant cycle like Earth, with hot days and cooler evenings. The planet shows significant temperature contrasts, largely due to its composition. For example, if Proxima Centauri B doesn't have an atmosphere, the temperature difference between day and night would be extreme. With gases or oceans to level out these extremes, the day side would become incredibly hot while the evening side would freeze. These sharp temperature contrasts interest stargazers, since they can reveal insights regarding Proxima Centauri B's atmosphere. With its strong infrared imaging skills, the James Webb Space Telescope can gauge the planet's intensity, giving significant pieces of information about its climate. However, the most fascinating part is that the James Webb Telescope's orbit around Earth is lined up with Proxima Centauri B's orbit, permitting it to notice the planet's constant cycles every 11.2 Earth days. If Proxima Centauri B has an atmosphere, the subsequent step is to concentrate on its chemistry to see if it could support life signs. Signs like oxygen, water vapor, and methane could indicate that the planet has conditions suitable for life. Viewing these components on Proxima Centauri B would reinforce the case for it being able to support life, prompting detailed estimations and investigations of the light passing through its atmosphere. But here's the catch. The James Webb Space Telescope can look at a couple of the closest planets that may be habitable. For a broader perspective on many more planets, researchers are eagerly anticipating the Extremely Large Telescope, ELT, which will start working in 2028. The ELT is expected to provide a clearer picture of what far-off planets' climates are like and how likely they are to support life. Mainstream researchers are looking forward to the new insights that the ELT and other future telescopes will bring. Meanwhile, the James Webb Space Telescope remains a significant tool for studying planets outside our solar system. Even with its limitations, it continues to provide valuable data that could change our understanding of the universe now and in the future. As we jump into the next section, we will further interpret these exciting discoveries, creeping closer to potentially pivotal disclosures. Looking forward, new space telescopes will aim to reduce the bright light from stars, making it easier to see the planets that circle them. This is like concealing your eyes with your hand to see better in bright sunlight. By diminishing the starlight, these high-level telescopes will be able to capture the faint glow from distant planets more effectively. This clearer view will assist researchers in studying the climates of these planets and determining whether they could support life. However, this is no simple task. Researchers must carefully identify gases produced by living organisms and those resulting from natural cycles like volcanic eruptions. They need to fully understand these distant planets so they can accurately identify signs of life and avoid being misled by natural events. The James Webb Space Telescope opens up additional opportunities for future discoveries. As we continue to explore space, we draw nearer to understanding more about the vast universe and our place in it. For as long as humans have existed, we've pondered whether we're alone in the universe. This question still drives many researchers today. Right now, the James Webb Space Telescope is analyzing various planets and moons, looking for signs that life could exist beyond Earth. The possibility that life could exist somewhere else in the universe is gaining traction, and this growing belief excites many about the chance of finding extraterrestrial life. In 1984, two American cosmologists, Jill Tarter and Thomas Pearson, started a project called the Search for Extraterrestrial Intelligence, SETI. They created a non-profit organization to listen for radio transmissions from space, hoping to find something from intelligent creatures. They use radio waves because these transmissions can travel significant distances without losing strength. The Allen Telescope Array in California, which involves 42 radio telescopes, is at the core of their work. Despite SETI having listened for more than 30 years, they haven't yet found any obvious indicators of extraterrestrial life. However, Jill Tarter remains hopeful. With today's advanced technology, she believes a major revelation could be just around the corner. She dreams of a global effort to find out if we are alone in the universe. Recently, excitement grew when NASA reported that the James Webb Space Telescope could have spotted something that resembled artificial light from a city on a nearby planet. The James Webb Space Telescope, situated 1 million miles from Earth, is significant for space exploration. It sends back detailed data about the most ancient pieces of the universe and is particularly designed to capture details we've never seen. This helps us learn more about how galaxies, stars, and planets form. Stargazers are utilizing the James Webb's advanced tools, like its precise camera and special filters, to concentrate on the light from stars and planets. By focusing on specific types of light, the telescope assists researchers in determining the physical and chemical composition of distant worlds. However, this isn't the most astonishing part. The James Webb Space Telescope goes beyond simply observing. It actively studies the atmospheres of different planets, looking for even the smallest indications of something beneath the surface. With its unmatched ability to explore the universe, the James Webb Telescope is driving us into a new era of discovery. Scientists have recently made some educational discoveries in the universe. They found significantly more material hidden in massive galaxies than they ever expected. These discoveries are pushing researchers to reevaluate their thoughts about how the universe began and evolved. Each new revelation from the James Webb Space Telescope brings us closer to understanding the most distant reaches of space and what life could exist beyond our planet. With the help of the James Webb Space Telescope, researchers are probing deeper into space than ever before, gathering data on distant worlds that could be useful in answering fundamental questions about these exoplanets. Only 20 years ago, our understanding of planets outside our solar system was minimal. But since then, cosmologists have identified over 4,000 exoplanets orbiting various stars. This demonstrates how strong our curiosity and technology have become. NASA believes these discoveries are just the beginning, suggesting that there could be trillions more exoplanets waiting to be found. As scientists continue their space investigations, they are eager to find where extraterrestrial life could exist. Sometimes they come across signs that suggest they are on the right track. For instance, the Galileo spacecraft made an accidental discovery near Jupiter that indicated possible vegetation. This was a significant moment, marking the first discovery of what is known as a biosignature, specifically the vegetation red edge. This method identifies life by concentrating on how light glistens off it. Now, the James Webb Space Telescope is prepared to explore further into the search for extraterrestrial life, focusing on planets that orbit within the habitable zones around their stars. If these signs of life are confirmed, they could revolutionize our understanding of the universe and our place in it. The search for life beyond Earth has reached phenomenal levels of complexity, with the advent of advanced space telescopes and observational advances. As astronomers continue to push the limits of what's possible, they are not just investigating the physical attributes of distant exoplanets, but also delving into their potential to harbor life. The technological advancements that have emerged over the past few decades are integral to this mission. One outstanding improvement is the advancement in spectroscopy, a method that analyzes the light emitted or absorbed by objects in space. By studying the spectra of light from distant exoplanets, researchers can determine the chemical composition of their atmospheres. This technique has already provided significant insights into the atmospheric conditions of several exoplanets, revealing the presence of gases like hydrogen, helium, and carbon dioxide. These discoveries help in assessing whether an exoplanet could have conditions suitable for life. Another exciting frontier is the investigation of exoplanetary atmospheric conditions. Understanding these patterns can provide clues about the environments of distant worlds and their potential habitability. For example, the discovery of seasonal variations in atmospheric conditions could indicate the presence of liquid water, a crucial element for life as we know it. Scientists are also researching the potential for extreme weather phenomena, such as intense storms or temperature fluctuations, which could impact the habitability of an exoplanet. The search for biosignatures or signs of life is an area of intense focus. Beyond the traditional search for oxygen and methane, researchers are exploring other potential biosignatures, such as complex organic molecules and unusual atmospheric phenomena. The James Webb Space Telescope, with its advanced spectroscopic capabilities, is well suited to this task, offering the possibility to detect these subtle yet significant indications of life beneath the surface. In addition to direct observation, theoretical models play a vital role in guiding the search for extraterrestrial life. These models help researchers predict what types of signals or conditions may be present on exoplanets based on known principles of physics and chemistry. They also assist in designing experiments and missions that could test these predictions. For example, models of exoplanet climates can simulate the potential effects of various gases and environmental conditions, guiding future observation strategies. Moreover, the incorporation of artificial intelligence, AI, into space exploration is revolutionizing data analysis. AI algorithms are increasingly being used to sift through the vast amounts of data collected by space telescopes and other instruments. These algorithms can identify patterns and anomalies that may be missed by human observers, providing new insights into the nature of distant worlds. Global collaboration is also playing a significant role in the advancement of space exploration. Researchers and scientists from around the globe are working together to share data, resources, and expertise. This collaborative approach enhances the overall understanding of exoplanets and accelerates the pace of discovery. As we look ahead, the continuous improvement of space technology and scientific methods promises to bring us significantly closer to answering one of humankind's most profound questions. Are we alone in the universe? The ongoing efforts and innovation in this field highlight the remarkable progress we are making in our quest to explore the universe and understand our place in it. With each discovery, we gather not only data but also hope. Hope that one day, the answers we seek may reveal that we are not alone, that somewhere out there, life flourishes in forms we have yet to imagine. The James Webb Space Telescope is not just a tool. It is a beacon guiding us through the vast darkness, illuminating the path to new worlds, new ideas, and new possibilities. The future of our exploration awaits, filled with the promise of the unknown and the excitement of what lies ahead.